Hi there and welcome to another video for the Edexcel Further 1 Pure Maths course. In this video we are going to talk about the parabola and talk about its parametric form. Now, looking at the scheme of work, we did everything we needed on a parabola. The one thing I didn't mention was that you need the idea of a parametric equation for a parabola. The idea of at squared 2at, it says, as a general point on the parabola is all that is required, and this is the formula up here. It's just a sort of a mention, really. There's no big deal about this idea, but it comes up in some questions, and I'll show you a question it came up in. Right, this was our parabola before, how we described it. You will remember I said it was the locus of all points that are the same right angle distance from the directrix as from the focus. The focus is the coordinate a0, a is some positive number. The directrix has equation x plus a equals 0. The parabola is symmetrical about the x-axis also, and it goes through 0, 0, which we call the vertex. They were the big ideas. Now, I want to, if you'll remember, what was the Cartesian form of this equation? Well, the Cartesian form, so I'll just write the Cartesian first of all, was y squared is equal to 4ax, where a is this number that is to do with the focus and directrix. Now, the parametric form, there's no way of deriving this as such, it's just convention. The parametric form is as follows. Y is given, x is given as at squared, and y is given as 2at. Okay, that is a function of t, as we talked about a parametric needs to be, and that is a different function of t, as we talked about. Now, why does this work? Well, it just works because t was chosen as such, and it works with this equation. If we substitute 2at in here, we would get 4a squared t squared. If we substituted in at squared here, we would get 4a multiplied by at squared, and the two are clearly equal, and so it works. So setting up in this way just works. That's the only point of it. So there's no way of deriving this. This is just something you need to be able to know. And going back to our scheme of work, the idea of a parametric equation for a parabola, i.e. it has x is equal to at squared and y is 2at, that's all you need. Now, the key thing with this is any point on the parabola, say any point, has the coordinates x, y. Okay, but equivalently, any point would also have the coordinates at squared, because x is at squared, and 2at. Now, sometimes, like when we derive the Cartesian form, it's easier to use x and y's. Other times, it's easier to use at squared and 2at. Also, sometimes we're just told which one to use and we have to be able to do it. So we have to be able to think of a parabola in that way. That's its Cartesian way, we have to know that. We also have to be able to think of it in its parametric way. And we need to be able to think of any point on the parabola as some point xy or some point at squared 2at. And that is everything that they're asking us for here. So I thought to show you how it might come up, I'll show you a typical question and we'll work through that, and then I'll set you some exercises from the book to make sure you understand all the ideas here. Right, here's an example. This might take us a while, it's a fairly detailed one. The parabola C has equation y squared is 4ax. That's a general equation, it doesn't tell you a. It tells you that the point 5 over 4t squared and 5 over 2t is a general point on C. This is very important information. That is on your curve, that is on your parabola. It asks you to find the Cartesian equation of C, i.e. we know it's of that form, but we want to know what A is in particular. Right, now for part A, parametrically I know any point on the curve, any point pxy on the curve could also be written as at squared 2at. Right, now we're told a point on the curve here, so I know that at squared must be the same as 5 over 4 t squared, and I know that 2at must be the same as 5 over 2t. Clearly then, just comparing both these, it works in both cases. There's t squared, there's t squared. A must be 5 over 4, right? A must be 5 over 4. And similarly here, just comparing t with t, 2a must be 5 over 2, so 1a must be 5 over 4. So we know the Cartesian equation of a curve is y squared is 4ax, but we know a now, it's 5 over 4, so y squared must be 4 multiplied by 5 over 4 times x. There's a 4 multiplying on top, a 4 multiplying on bottom, they cancel, so therefore y squared is equal to 5x, and we have done part A. Right, let's just write that down then. Y squared is 5x and A is equal to 5 over 4. That's what we got from part A. Then it tells us that the point P lies on the curve and it has y coordinate 5. Find the x coordinate. Okay, so for part B, we know it lies on the curve, so we know therefore that it satisfies 5 over 4t squared and 5 over 2t. That's any point on the curve. Now we're told that the y coordinate has value 5. So I know that 5 over 2t must be equal to 5. The y coordinate that we're told. Okay, so then dividing by 5 over 2, we would therefore get that t is equal to 2. So for this particular point P, we know t is 2. But we're asked the x-coordinate. So therefore the x-coordinate, well parametrically, we know it's 5 over 4 times t squared. But we've worked out that t is 2, so x is 5 over 4 times 2 squared, which is 5. So the point P, therefore, in particular, in this case, is the point 5, 5. And we've done part B. Right. Just going to write here that P was the 0.55, the equation was y squared is equal to 5x, and then we've done everything from the previous parts. Now the next part, it says Q lies on the directrix of C, where y is equal to 3. Okay, so Q is some point that lies on the directrix of the curve and its y coordinate is equal to 3. The line passes through the points, the line L passes through the points P and Q. Find the coordinates of Q. Okay, time for a picture. Should draw a picture here, just to get in our head what on earth is going on. So, we've got our parabola y squared is 5x. And we know that A is 5 over 4. So our key point here is 5 over 4, 0. And we know that our directrix is the equation x plus 5 over 4 is equal to 0. So I'll draw out a directrix. Just do it in the red line, it doesn't matter, it's a bit bolder. There's my directrix. Okay, and there's my focus. And I know the curve looks something like this. I know that from my work on parabolas. It looks something like that. Now I'm told the point Q lies on the directrix where y is 3. So Q is here, and Q has coordinates, well x coordinate negative 5 over 4 and y coordinate 3. Okay. I'm also told that the line passes through the points P and Q. Now P from the previous part was 5, 5 and it was on the curve. So 5, 5, let's say, is somewhere here. So the line passes through PQ, find the coordinates of Q. Well, I've already found the coordinates of Q easily. The coordinates of Q for part C are simply negative 5 over 4 and 3. That was the easy part. D, what are we looking for here? We are asked to find an equation for L. Now remember, L passes through the points P and Q, and give it in the form ax plus by plus c is 0, where a, b and c are integers, i.e. whole numbers. We want the equation of the line that goes through P and Q. Now, in general, to find an equation of a line, we can do it quite easily as long as we know the gradient of the line and we know a point on the line. Now, in this case, we're lucky, we actually know 2 points on the line. Q is negative, that should be negative 5 over 4, 3, and P here is 5, 5. But what we don't know is the gradient, so let's work it out. The gradient of this line, you will remember the gradients is the difference in y's divided by the difference in x's. So here, the difference in y's between P and Q is 5 subtract 3, divided by the difference in x's is 5 subtract, well this is negative 5 over 4. Okay, so this calculation is 2 over 6 1/4, 2 over 6 1/4, and you get 8 over 25. You get 8 over 25 as your m. Now, I know the equation of a straight line. If I know the gradient and I know a point on the line x1, y1, it's given by the formula y minus y1 is mx subtract x1. Okay? Now, a point on the line is either negative 5 over 4, 3 or 5, 5. I'm going to use 5, 5 because there's no fractions there. So substituting in, y subtract 5 is equal to 8 over 25, x subtract 5. Multiply both sides by 25 and expand the 8 out inside that brackets there. I get 25y subtract 125 is equal to 8x subtract 40, and then subtracting 25y off both sides and adding 125, I would get 8x subtract 25y, and then I would get myself 85, so I'd get plus 85, and there I go, I have the equation of the line in the form they stated. Now, that's all I wanted to talk about in this video. What were the key ideas in that example? Well, sometimes the examples get more complicated than you would have hoped. There's quite a lot involved here. However, key ideas. Remember the Cartesian form of a parabola. Y squared is 4ax. Remember the parametric form of a parabola. X equals at squared and y is 2at. Use those interchangeably as and when they're necessary. The key idea, though, is when you're dealing with these things, finding points P and Q and a line between them, draw a picture. That helped us get C so easily, and it helped us get D nice and easily too. So always, always, always draw a picture to help yourself. Now, to consolidate the work, I would suggest you read pages 48 to 51, work through a good example in that slide, which is example 7. Then do every question on exercise 3C. Tune in then for the next video on rectangular hyperbolas. Thank you very much for watching.